All right, so in this session, we're going to be talking about limiting reagents. So this is an introduction to solving these types of problems. And hopefully by now you've read carefully section 12.3 in the textbook. And that's going to be a big help to us in understanding what's going on with these kind of problems. But let me introduce it with an analogy, and then we will quickly move into actual, chemical reactions and see how this idea of limiting reagents is applied. And I think you'll see why it's relevant and why we have to know how to handle these things. Okay, so let's start with a model, an analogy involving bacon hamburgers. I left off the cheese for simplicity. I just want to have two ingredients here to deal with. So let's say that we have a process where to make a bacon cheese or a bacon hamburger, we want to have 3 strips of bacon for each hamburger patty. Okay. So if that's the recipe, then let me introduce a situation where maybe we have 2 hamburger patties available. All right, so that's how much we've got. And so the question is, how many strips of bacon would we need in order to assemble 2 complete bacon burgers? And I think you can see, from the stoichiometry, from the ratio of hamburger to bacon, it's pretty obvious, right? It's x is going to be 3 times 2 or 6, right? So if you need 3 strips of bacon for every 1 hamburger patty, and you have 2 hamburger patties, then it's pretty straightforward. You're going to need 6 strips of bacon, and that will allow you to make how many bacon burgers? That's right, 2 complete bacon burgers. Okay, so that's all pretty straightforward, and don't forget, the way we would set this up if it were a more difficult situation, we would start by writing, okay, the number of bacon strips equals, okay, what do we have? That's right, we were given 2 hamburger patties, and then you multiply that by the ratio, so 3 strips of bacon over 1 hamburger patty, and you'd cancel out the burgers, and you would get 2 times 3 or 6 strips of bacon. Okay, so that's how we handle this formally using our calculations. But let's say we have a little bit different situation. Let me clear this space here. Okay. Let's say we've got, let's say we have 2 strips of bacon, or I'm sorry, we have 2 hamburger patties, and this time we're given 5 strips of bacon. Okay, so you come into work, these are the materials that you have to work with, and you're faced with the following 3 questions, okay? And I know these seem a little bit contrived in the context of bacon burgers, but they are good analogies for the situation we'll face with chemical reactions. Question number 1 is, which ingredient, pardon my writing, runs out first? Okay, so if you start with these amounts of ingredients and you begin to assemble the bacon burgers according to this stoichiometry, which ingredient are you going to run out of first? Okay, so that's a key question that we have to be able to answer in the context of chemical reactions. The second one is, how many complete bacon burgers can be made? Okay, so that's key. And then finally, and this is a little bit secondary, it'll be obvious once we find the answer to the first question, but we will be asked which ingredient was in excess. Okay, so if you have two ingredients, once you've determined which ingredient runs out first and therefore is limiting, then by definition the other one is there in excess. Okay, so these are the three questions we got to grapple with. So in order to kind of see how this works, let's imagine that you're making bacon burgers, and you take one hamburger patty. So you take one, so I'm going to put a -1 here. So to go from this step to this step, we've depleted one, and in the process, you're going to need 3 strips of bacon, right? So to go from during the process of making the first bacon burger, you're going to lose 1 hamburger patty. So the hamburger patty count is going to go from 2 to 1, and you're going to have to use 3 of the 5 strips of bacon to make that first bacon burger. So now your bacon count is going to go down to 2. So whereas you started with 0, you now have 1 complete bacon burger. And then at this point, if you want to go one more step and assemble the second bacon burger, I think you can see you're going to run into a problem real fast, right? I mean, you've got the hamburger patty, you only need 1, but you're short 1 strip of bacon, right? You only got 2. So that makes the bacon, that is the ingredient that in a sense is running out first, right? Because if you just had 1 more strip of bacon, you could make a complete bacon burger. But the bacon is the one that is limiting, in the sense that that's the one that you're short on, and you're gonna have to stop production, right? So so question number 1, I'll put answer number 1. Bacon. Bacon is the ingredient that runs out first. Question number 2, how many complete bacon burgers can be made? Only 1. And question number 3, which ingredient was in excess? Okay, which one was not holding you back? And that's the hamburger. Okay, so conceptually, I hope that this situation is clear, and I hope you can see why the answers to these questions are, the way I'm presenting them, given the situation that we have. All right, let me get my clock up here so I can see how much time we have left. Okay, so hopefully you followed along with that one. Let's do another one. Let's set this up again. I'm going to use the same set of ingredients. There we go. So 1 hamburger patty takes 3 strips of bacon to form 1 bacon burger. All right, and this time, let's say we have 7 hamburger patties, and when we show up for work, we have 23 strips of bacon sitting in the pan. All right. Well, now I think you can probably see already what's going to happen. I think you can see that we have enough bacon to completely utilize the 7 hamburger patties, right? And let's kind of sneak up on it. Let's see how this would work. So when we make the first 6 bacon burgers, okay, so we're gonna use 6 of the hamburger patties. So we'll go down from 7 to 1, and in the process, when you make those 6 bacon burgers, you're going to need 6 times 3 strips of bacon, which is 18. So you will subtract 18 from this, and now you have 5. And in the process, you went from 0 to 6 bacon burgers, right? So 6 hamburger patties plus 18 strips of bacon. That is exactly what you need to make 6 bacon burgers. And what you have at that point, what you have left of your initial ingredients is 1 hamburger patty left, 5 strips of bacon. So then, if you wanted to, make another one, um, you have 1 hamburger patty, 3 strips of bacon, and now you'd have 0 hamburger patties left. You would have 2 strips of bacon left, and now you've gone from 6 to 7. And you have 2 bacon strips left over. So if you wanted to make another one, well, the thing that ran out first was the hamburger patty. Okay, so in answer to our first question, what was the limiting ingredient? Well, the limiting ingredient here was the hamburger. Okay, so that is the limiting ingredient. That's the one that ran out first. Answer to question number 2, how many complete bacon burgers could we make? The answer is 7. And the answer to question number 3 that we posed earlier, which one was present in excess? That would be the bacon this time. Okay, all right. So that's the opening example. Now let's see if we can get in before my time runs out here, an actual chemical example. All right. So let's say we have a process where we're going to react a compound called ethylene with oxygen. And in this particular, well, as you may guess, the ingredients to this combustion reaction are carbon dioxide and water. And when you balance the reaction, you get this. And in the problem, it says that we're given 2.70 moles of ethylene and 6.30 moles of oxygen. And the questions are the same that we posed earlier with the bacon burgers. So question number 1, which of these 2 reactants is going to be limiting? Which one will run out first? And I think you can see by inspection that if for every 1 mole of ethylene you need 3 times as many moles of oxygen, I think you can see that the oxygen is going to be limiting, all right, because 2.7 moles of ethylene is going to require 8.1 moles of oxygen. So what I did here is I just took 2.7, the amount we were given, and I multiplied it by this, by 3, by the 1 to 3 ratio. And if we really do want to react all 2.7 moles of ethylene, you're going to need 8.1 moles of oxygen. And clearly we don't have that. We just don't have it. So you can see by inspection that that the oxygen is the limiting reactant in this case. And now you're probably wondering, hey, I was reading the section and it says that the title of this section is limiting reagent. But Dr. Hammer, you said limiting reactant. Well, yeah, reagent and reactant are sometimes used interchangeably in chemistry. So, if we're going to run this reaction, chemists some of the times would refer to the ethylene and the oxygen as the reagents. Let's go get the reagents for this reaction. And since presumably the people that were working together knew that this was the reaction, they would assume that the ethylene and the oxygen were the reagents. Okay, so that's just a naming thing. All right, so I'm just about out of time, so I'm going to stop here, and then we'll continue this problem on part 2 of this video.